Hey, what's going on, guys? Today we're looking at 12.2. All right, transforming exponential logarithmic functions. Let's go ahead and get right in. Hey, this first graph right here. Oh, actually, let me start by saying, guys, all the transformation rules are the same from function to function, from quadratic to linear to exponential to logarithmic to cubic. You name it, man. Absolute value, radical. We did it all. All right. All the rules are the exact same. You just got to know when to apply them and what's going on. This first problem right here, I'm going to do this in blue. Well, I do it in green so you guys can see it, so I can point out a couple things. Let's go to the graph. We got 2 to the power of x minus 4. This is the parent function, 2 to the x. All right, so everything that we do will be done to this function, 2 to the x, which is the parent function. This is the graph of 2 to the x, 2 to the power of x. This is it right here. It's the parent function. All right, a couple different ways to look at this is I'm going to identify the points that we can actually see. All right, the points we can actually see. So if you look at this graph, the points that the intersections that I can clearly identify, that point right there is 0, 1. All right, this point right here is going to be 1, 2. This point right here is, right there is 2, 4. And this point right here is 0, 4. All right. 0, oh, excuse me, I'm sorry. That's negative 4, 0. All right. Now, with these points right here, guys, I can make all my rules do what I want them to do based off this. And the first equation was 2x minus 4. All right. Well, was it minus 4? Yeah, minus 4. All right. What that tells me is, you see how everything that is outside of the x, all right, see how this is down here, all right, outside the x, all right, and it's minus 4. That tells me to go down 4. So I'm going to take all the points I can see and go down 4. 1, 2, 3, 4. Move this down 4. Move this point down 4. And even move that down 4. All right. This is going to be, well, let me do that. There we go. My new graph. All right. Now, all I did was, again, this is the y, all right? This is the y. Move y down 4. So take all these y values. 0 minus 4, negative 4. 1 minus 4. I'm sorry, this one. 1 minus 4, negative 3. 2 minus 4, negative 2, which is this point right here, 2 minus 4. And this point right here, 4 minus 4 is 0. I just moved them down, okay? And now I got to identify the horizontal asymptote, all right? The horizontal asymptote for this one. All right, the horizontal asymptote, guys, is y because it's a horizontal line, all right, from left to right, horizontal asymptote. So this graph, guys, see how this original graph doesn't cross the y equals 0 line? It doesn't cross that line right there. Well, right here, it doesn't cross negative 4. All right, and an easy way to tell this for exponential is, look, that went down 4. Negative 4, down 4. That is my horizontal asymptote. Y equals negative 4. All right, that's my horizontal asymptote for this one. All right, and then the next thing is said up here, if you guys read the directions, all right, it said what's the asymptote and the y-intercept. The y-intercept, we can see it right here. All right, y-intercept, 0, 0, negative 3. Or you could just put y equals negative 3. All right, either one of those. All right, say it's multiple choice on your quiz or on your test, you'll see it. All right, so make sure you can identify your y-intercept and your horizontal asymptote. All right, and again, guys, all right, see how this is negative 4? That tells me where my asymptote is. Even on this one, all right, this says plus 3 right here. It's outside, not like right here. See how this is minus 2? That's not the horizontal asymptote. This right here, this is the horizontal asymptote. So this one will be 3. The horizontal asymptote will be y equals 3. For this one, the horizontal asymptote will be y equals negative 6. All right. Let's say, look at the parent function. the parent function 2x. Well, see how there's not a plus a number right here? We'll just say plus 0, right? Because there's nothing there, so plus 0. That's why this is the horizontal asymptote, y equals 0. Because it's plus 0. It didn't go up or down. It's plus nothing. So 0 is the horizontal asymptote, okay? So hopefully that helps, man, identify the horizontal asymptote when you have that type of problem. Let's go down here. This problem here. I'm going to do this one on the left right here, okay? So 3 times 2 to the power of x. Remember, this is the parent function. We multiply it by 3. So if we look at our table tells us when we multiply the parent function by a whole number that greater than 1, we stretch by 3. All right. So again, take these points that I can see. We're going to stretch them by 3. Now again, this is outside of the parenthesis. All right. This doesn't affect the x directly, so this affects the y value. All right. Just like over there in the other problem, it told us move down 3, it affected the y value. Down 4, it affected the y value. This one stretches by 3. And when something stretch or compress, you multiply the y values by 3. So this point right here is 0, 1. Well, the y value is 1. So I'm going to multiply that by 3. 1 times 3 is 3. All right. So that's my new y value. All right, I'm doing another color. That's my new y value. Even here, this is 1, 2. If I multiply that by 3, it would be 1, 6. All right. So 4, 5, 6 up here. All right. And then again, this value here. All right. This is negative 4, 0. Well, 0 times 3 is still the same thing. So that doesn't change, right? 0 times 3 is still 0. But guys, this is my new graph. All right. That's my new graph for this one here. 3 times 2 to the power of x. All right. Now, the thing I want to identify with the horizontal asymptote is still the same thing. All right, same rule. There's not a plus anything here, so plus 0. Well, my horizontal asymptote is still y equals 0. All right, it's still this imaginary line right here. Y equals 0. And then the intercept, the y-intercept changes. All right, but I can see that. All right, what's the y-intercept? Y equals, right here, 3. Y equals 3. And you can use your calculator. You can see it in your calculator if you just graph them, okay? For this next problem, all right, we have the negative out front. All right, the negative tells us the negative out front says, reflect across the x-axis. All right, so again, everything out front is not directed to the x, means it affects the y value. So this y value right here is 0, 1, right? 0, 1. I'm going to multiply the y value by negative. So that times 1 times a negative, the negative out front right here is negative 1. This point right here is 1, 2. All right, take the y value because the negative's outside. Negative 1 times 2 is negative 2. And then you have this one right here, 2, 4. Again, multiply that y value by the negative. So you get 2, negative 4. And 0 times the negative is still 0, so that doesn't change anything. But there's our graph. And then we got to answer the question about horizontal asymptote. By the way, again, this is the equation for this one. The horizontal asymptote is still here, y equals 0. Because again, nothing changed. I didn't move it up or down. And what's the y-intercept? Negative 1. Y equals negative 1. Okay. All right. Well, let's look on this back side. Guys, I'm telling you, the transformations does not change. Does not change at all. Brief intermission, man. Today's lesson is brought to you by white chocolate M&Ms. These are delicious, man. I've never seen these in the store, but these are good. All right. This is your parent function for log. All right. This is for regular log and natural log of x. All right. This is the parent function. They look the same. All right, because it's the same function, actually. All right, so here's what we do. We got two equations down here. Oh, by the way, I just want to show y'all this. Let me go over this with y'all. It's the same thing. All right, you see how this is x, but this is outside of the parenthesis? All right, it's outside the parenthesis, so that means up. Plus 3 up, minus 4 down. Inside the parentheses, make sure you do the opposite. Minus 2 means right 2. Plus 1 is left 1. All right. A outside that's larger than 1, stretch. Less than 1, compression. Remember, do the reciprocal. This is 1/5 inside the parentheses. 1/5 times x, stretch by 5. 3 times x, compression by 1/3, the reciprocal. Negative out front, across the x-axis, negative in the parentheses, across the y-axis. All the same rules, guys. Don't change regardless of the function. So, here we go. And I'm going to use the point I can see. I can see this one point right here. That point right there is 1, 0. 1, 0. So I'm going to use that to manipulate the whole graph. All right, I'm going to manipulate the whole graph. I also want to point out that, guys, you have a vertical asymptote right here. I don't know how much in depth you guys went in this in your class if you don't have my class, but oh yeah, right here. Note the asymptote and the x-intercept. So good. Note the asymptote. So you have a vertical asymptote. Vertical because it's a vertical line. All right, you're gonna have a vertical asymptote. In this case, it's 0. X equals 0. Vertical because it's a vertical line. You count like this: 1, 2. Well, this is 0. X is 0. All right, that's my vertical asymptote. X-intercept is 1. All right, that's my x-intercept. Hey, what's up? All right, so what you got to do is this. Take the natural log function. Remember, we had that one point right there. All right, I'm going to apply all these rules to this, okay? Here's what happens. Remember, here's your parent function, okay? It looks something like this. All right, and it went from there. It keeps going. I probably made mine a little too round, so let me just keeps going. Well, this tells me, first of all, I need to reflect it. So I flip this whole thing upside down. And then I need to move it plus 3. Inside the parentheses means left 3. All right, so I'm going to go 1, 2, 3. All right, I'll do that again. From here, left 3. 1, 2, whoa, 2, whoa, 2, 3. All right, this is 3. So that's where that point is now. All right, but remember, it flipped upside down. That negative right there tells me it flipped upside down. All right, so it flips upside down. All right, so this will be the new graph. All right. Now, let's identify this asymptote right here, the vertical asymptote. All right, I know that this is the vertical asymptote because, again, just like the horizontal asymptote with exponential, this right here tells me where my vertical asymptote is. I went over 3. All right, remember how right here, the parent function, log of x, it doesn't tell you anything in the parentheses. It doesn't say like plus a number. So we're going to go plus 0. What? That's your asymptote, your vertical asymptote. 0 is your asymptote. Here, all right, I went over plus 3 or left 3. That's my asymptote. 3 is my x equals negative 3. And again, it's negative 3 because I went left 3. So negative 3 is my asymptote. It won't go past that. If you did it in your calculator, made the table, this will never go past the negative 3 value for x, okay? But that red is your graph, all right? That green is the parent function. Oh, one more thing I didn't do, intercept. The x-intercept. The x-intercept right here, we have negative 2, 0. All right, negative 2, 0. Y-intercept, you would use your graphing utility device, and look at the table. Here, let's take a second and do it. So here, guys, I just wanted to show you, here's the parent function, ln of x. Here's the change we're making, negative ln of x plus 3. So now graph them. There's your parent function in the blue. And in the red, there's your negative ln of x plus 3. It reflected and moved right 3. 1, 2, 3. All right, and then, guys, it just turns up right here. 3 is your asymptote. All right, that's your asymptote. All right, so back to this. This one here, 5 log of x minus 2. All right, first thing, see this 2 is not attached to it. There's no parentheses here, so it's not horizontal, it's vertical. All right, it's vertical. Go back to that point that we had right there. And let me use another color. I'm going to stretch it by 5. All right, so that point is 1, 0. All right, that affects the y. All right, so this point is 1, 0. So it's going to be 0 times 5, that stays. But everything else will stretch by 5. All right, stretch by 5. Also, this tells me to do what? That minus 2 means move down to 1, 2. So move it down to like that. All right, move that point down 1, 2. All right. There's no horizontal. Like over here, there was a horizontal shift. All right. But since there is no value right here attached to the x, it's the same vertical asymptote of 0. All right, it's going to get really close to that line, but never cross it. All right, it just goes off. All right. But anyway, horizontal asymptote. Whoa. Y equals 0. I mean vertical asymptote, excuse me. X equals 0. All right, and then our intercept. You use your graphing device to find your x-intercept. All right. So let's see real quick. Oh, did I give an x-intercept for this one? Yeah. Y-intercept I didn't look up. So let's see what the x-intercept is for this one. All right. I wanted to show you guys something right here. See how this is minus 2? All right. With the equation, it's not in the parenthesis. So when you put this in your calculator, it automatically puts a parenthesis, guys. Like if you were to press log or even natural log. Like if I just press log, it puts a parenthesis. So when you put x, guys, make sure you close that. All right. If you do this, it's going to assume you mean this. And that's going to be a horizontal shift right. But you don't want a horizontal shift right. We know that it's outside. All right. So you got to put it outside like I did with this last problem. All right, outside the parenthesis, okay? All right, so when you look at the table, guys, I'm going to already tell you, man, it's not a precise 0. So it's not going to show it to you. The red is the transformation, all right? It's not going to show you the 0. So you'll have to use, remember the second trace function, and go to 0, all right, and find the x-intercept that way, okay? All right, now, let's go back to our problem. All right, last few problems, guys. This one right here, it says write each transform function. So we have the base function of 4 to the x. It's reflected across the both axes, actually, both. All right, so if you reflect across the x-axis, you got the negative out front. And if you reflect across the y-axis, then you're going to have the negative in front of the x. All right, and then move 2 units down. So when you move an exponential function 2 units down, you're going to put it out here, 2 units down. So that way it's not up here with the x, and then that's horizontal. This is 2 units down, okay? This next one here, we have, I'm going to write g of x for this one. I should have put g of x right here because it's no longer f of x. That's f of x. We'll call that g of x. So for this one, g of x of natural log, we're going to compress horizontally by a factor of 1/2. Or remember, horizontal compression is directly to the x. All right, but you got to do the reciprocal in here in the parentheses. So if I factor this, if I compress it by 1/2, I'm going to write the reciprocal multiplied by 2. All right, and then we move it 3 units to the left. So remember, if I move it 3 units to the left, that also goes in the parentheses. I'm going to move it. I'm going to go plus 3 because you do the opposite right here. So plus 3, we'll move it 3 units to the left. Next, we have log. All right, and log, we're going to stretch it vertically by a factor of 3. So we know that goes out front, 3 log. And then we're going to translate 5 units up. So 3 log of x, guys, don't forget your parenthesis right there. All right, and then we're going to go up 5 units, plus 5 outside. Okay, And then for this last one, guys, the height of a dogwood tree in feet at age X years can be modeled by this function right here. All right, describe how this model is transformed from the parent function. So here's the parent function. Sorry about that bell, the period's over. There's the parent function. This 2 tells me it's vertically stretched. Vertically stretched. That's an E. H. Vertical stretch by 2. Ooh, man, the pen strip by 2. All right, and then that plus 2 right there tells me we move left 2. All right, and then that plus 3 tells us we went up 3. All right, so the tree stretched taller. It stretched wider. Excuse me, stretched taller. It moved, for whatever reason, the tree moved to the left. All right, I guess it grew to the left. All right, but it moved to the left by 2, and then it moved up. Moved up 3. All right. Hey man, that's that, guys. Hopefully this helped clear up any type of errors you guys may have had. All right. Hey, good luck and see you tomorrow.